Course and mechanism of cellular injury. Cell injury results when cells are stressed so severely that they are no longer able to adapt, or when cells are exposed to inherently damaging agents or suffer from intrinsic abnormalities. Different injury stimuli affect many metabolic pathways and cellular organelles. Injury may progress through a reversible stage and culminate in cell death. Most injury stimuli can be grouped into the following categories: oxygen deprivation. Hypoxia or oxygen deficiency is the extremely important and common cause of cell injury and death. The cause of hypoxia includes ischemia and inadequate oxygenation of the blood. Chemical agents. An enormous number of chemical substances can injure cell, even innocent substances such as glucose or salt, if sufficiently concentrated, can so derange the osmotic environment that cell injury or death results. Agents commonly known as poisons cause severe damage at the cellular level by altering membranes permeability, osmotic homeostasis, or the integrity of an enzyme or cofactor, and exposed to these poisons can culminate in the death of the whole organism. Other potentially toxic agents are encountered daily in our environment. These include air pollutions, insect deaths, and other social stimuli such as insinos. Physical agents, trauma, extreming of temperatures, radiation, electric shock, and sudden change in the atmosphere pressure all have wide-ranging effect on cells. Infectious agents. These range from submicroscopic virus to meter-long tapeworms. In between are the rickettsia, bacteria, fungi, and protozoas. Immunologic reaction. Although the immune system defends the body against pathogenic microbes, immune reactions can also result in cell and tissue injury. Examples include autoimmune reactions against one's own tissues and allergic reactions against environmental substances in genetically susceptible individuals. Genetic defects. Genetic defects can result in pathological changes as conspicuous as the congenital malformation associated with Down syndrome, or as subtle as the deficiency of functional protein, or accumulation of damaged DNA or misfold proteins, both of which trigger cell death when they're beyond repair. Variations in the genetic makeup can also influence the susceptibility of cells to injury by chemicals and to other environmental insults. Nutritional imbalance. Nutritional deficiencies like protein, vitamin remains a major cause of cell injury. Ironically, excesses of nutrition are also important causes of morbidity and mortality. Moreover, diets rich in animal fat are strongly implicated in the development of atherosclerosis, as well as increased vulnerability to many disorders, including cancer. All these above injuries can link with the resulting cellular and tissue manifestations via biochemical mechanisms. And these biochemical mechanisms are very complex, interconnected, and tightly interwoven with many intercellular metabolic pathways. The cellular response to injury stimuli depends on the type of injury, its duration, and its severity. The consequence of our injury stimulus depend on the type, status, adaptability, and the genetic makeup of the injured cell. ATP is produced by phosphorylation of the ADP during reduction of the oxygen in the electron transport system of mitochondria. In addition, The glycolysis pathway can generate ATP in the absence of oxygen, use glucose. Tissue with a greater glycolytic capability, such as liver, are able to survive loss of oxygen and decreased oxidative phosphorylation better than other tissue with limited capacity for glycolysis, such as the brain. Depletion of ATP to less than 5% to 10% of normal level has a widespread effect on many critical cellular systems. Mitochondria can be damaged by increase of cytosolic calcium, and so they are sensitive to virtually all types of injury stimuli, including hypoxia and toxins. There are two major consequences of mitochondrial damage: formation of the mitochondrial permeability transition pore and activation of apoptotic pathway. The opening of this channel leading to the loss of mitochondrial membranes potential and the pH changes, resulting in failure of oxidative phosphorylation and the progressive depletion of ATP, culminating in necrosis of the cell. The mitochondrion contain protein related with apoptosis, including cytochrome C. Increased permeability of the mitochondrial membranes may result in leakage of this protein into the cytosol and death by apoptosis. Early loss of selective membranes permeability, leading ultimately to overt membrane damage, and the future of most forms of cell injury. The plasma membranes can be damaged by ischemia, virus, microbial toxin, lactic complement components, and a variety of physical and chemical agents. Several biochemical mechanisms may contribute to membrane damage, including decreased phospholipid synthesis, increased phospholipid breakdown of the membranes, reactive oxygen species, cytoskeleton abnormalities, and lipid breakdown abnormalities. Free radicals are chemical species with a single unpaired electron in the outer orbital. Such chemical states are extremely unstable and readily react with inorganic and organic chemicals. When generated in cells, they avidly attack nucleic acid as well as a variety of cellular proteins and lipids. In addition, free radical initiate autocatalytic reaction. Molecules that react with free radicals are in turn converted into free radicals, thus propagating the chain of the damage. Three reactions are particularly relevant to cell injury, mediated by free radicals: lipid peroxidation of membranes, cross-link of the protein, and DNA fragmentation. That's all for this section. Thank you.